our assignment for Wednesday, March 20th. As you can see here, for the advisory schedule, we're doing HASBOT Activity 2, which is kind of a longer activity. And when you're done, there's an exit quiz in Schoology. Okay, so I'm going to go ahead and I'm going to go to learn. If I can type it in here, learn.concord.org. And I am logged in already, it appears. So as you go into HASBOT, learn.concord.org, and sign in with your Google account, the first page looks like this. We're doing activity 2, and you can see it has several parts to it. We're going to go through it relatively quickly. So let's start with page 1. Page 1 starts with a video, and it talks about what will Earth's climate be in the future. And so we're going to take a look at some predictions for the future. What it says here is you're going to examine climate data and modules, and we're going to click on this video. There's no sound to the video. I think I can go ahead and play it, and it should be okay. Okay. All right, so what this video is showing, I'll pause it here. If you look at the bottom, those are the years. These are 5-year spans of time. And if I started back at the beginning, you can see it starts in the year 1880. Do you remember the graph we saw for HASBOT Activity 1, where it showed the surface temperature between 1880 and 2009? Well, this is a map that shows that using different colors. So blue areas are temperatures that were colder than the 1950 average, and yellow and red and orange ones are warmer. So I'm going to let it play. We're going into the 1900, 1910s, 1920s, 1930s, 1940s, and 1950s. So 1950, this is the baseline. We said 1950, everything, the blue is colder than 1950 on average, and the yellows are warmer. Well, you see a little each here because this is, you're going to have about 50% either side. Now, as we see, as we're getting into the 1960s, 70s, you're starting to see a change here, especially into the 1980s. There's the 1990s. You can see a cold area by Greenland, right? All the way to 2019. So 2019, you can see the departure from average, how it's much warmer. So let's take a look at your questions. What do the colors indicate about the change in average temperature over time from 1884 to 2019? Okay, the change in average temperature, you can see, has increased over that time. And in the past 50 years, where has the temperature changed the most? What we'd like to point out there is, let me skip back to the end, is the biggest change is occurring in the Arctic. Okay, the high latitudes. We're getting the most warming in the Arctic areas. Okay, let's go to page 2. This graph shows the temperature change from 1880 to 2019 compared to the average temperature of 1950 to 1980. So they said, okay, 1950 to 1980, we're going to call that average. So that's this kind of area right here. Anything above that, can you see on the y-axis where that's pretty much the zero range? Negative numbers were colder than that 1950 to 1980 average, and going up here positive are warmer than that. Okay. Each point is an average of the temperature for the preceding 12 months. So every year is the gray shaded area, so the black dots. The gray shaded area is actually showing that's the uncertainty. What does that mean? Well, if you look at nowadays, we're pretty certain about the data. I'm going to zoom in if that's okay. If we look at more recent data, there's not a lot of gray above and below the point. But as we go back in time, you should notice that gets wider. If you look way down at 1880, there's a large range. Why? Because we didn't have as much measuring going on at that time. The technology was different. We might not have had global temperatures as accurate. And so the shaded area, the gray area, shows the level of uncertainty for the data point. So what that means is that this dot, can you see where my cursor is, could be anywhere from up here to down here. It's that range of gray. And as we get closer to present day, that uncertainty gets smaller because we have better data collecting measures. Got it? Okay. Question, describe the average temperature change from 1880 to 2019. Well, you should say that 1880, it was kind of increased slowly, and then it increased a little more rapidly as you got closer to 2019. Trends of the past, part 2. This one talks about the gray shaded area that I talked about, the uncertainty. So now let's look at the questions. Question 4, why is the curve between 1950 and 1980 relatively flat? All right, so what they're asking there is the idea that that's your average. So we're saying that this is flat. There was no departure from this area. It's relatively flat, so we're calling that the average. Temperature really didn't change a whole lot over time. Question 5. The gray shaded areas are called error bars. I refer to them as uncertainty. They indicate the range of uncertainty that scientists have about the data. Why do you think the error bars are smaller in the late 1900s and 2000s than the 1800s and 1900s? So understand that we have better technology in recent years, so our confidence rating is higher, right? The error bars are smaller. The farther you go back in the past, the less data we have, and the less accurate data, probably. Question 6. Why is the black line so much more variable than the red line? The black line represents the year to year, right? And the red line is it's like a 5-year average. So they're averaging the numbers there for the red line. Yeah, it says up at the top. So that's why, right? I don't think we have to harp on that any farther. Predicting the future. This graph shows the 5-year running average from 1880 to 2010. With the red line you saw on the previous page, it's clear that the past temperature data has a trend. Does the past trend help us to predict the future? So here we have 3 options, A, B, and C. Okay, so the red line is where we are as of the end of this data collection. So it looks like at about, I can't really see, 2007 or whatever. And so our job is to take a look at, what do you think will happen next? Do you think the line will be A, B, or C? So question 7, what's the overall temperature trend between 1880 and 2010? Between 1880 and 2010, hopefully you said that it was a warming. Question 8, what was the temperature change between 1920 and 2000? To do that, you're going to have to find the temperature at 1920. So I'm going to zoom in. At 1920, we started off at a minus 0.2. You see where that is, 1920, a minus 0.2 temperature from the average. And the question was to compare that to the year 2000. The year 2000, which is this line, okay, that intersects right here, about 0.45 above. So 0.45, know where I'm getting that? So that's 0.4, 0.5, 0.6. So halfway in between 0.4 and 0.5 is what I'm estimating to be 0.45. 0.45 plus another 0.2 would be 0.65. You can do that in your head. So the best answer they have here is 0.6. I'm going to check my answer. And that is correct. Then the 3 lines, this has you predict what you think is correct. On the graph are possibilities. Which line best shows what you think will happen? Do you think we will continue to increase like A? Do you think we'll level off like B? Or do you think temperatures will decrease for C? Give me your answer. Explain your answer. How certain are you, and what influenced your certainty rating? Okay. So so I can move on, I have to go back a little bit, or else it won't let me go forward without answering that. Page 5, way back in time. It says the data for the previous graphs were obtained with thermometers. What if scientists wanted to know temperature before humans started collecting data? Scientists have found a variety of techniques to determine the temperature before the existence of thermometers. By the way, this is called paleoclimatology. Paleo means ancient, and so it's paleoclimatology is the study of ancient climates. By studying glaciers and ice sheets, scientists have been able to infer global temperatures over the past few 100,000 years by studying the gases and other materials that are trapped in the ice. We talked about this in class yesterday. Scientists take ice cores of the ice by drilling holes deep into glaciers and ice sheets. Since the layers at the bottom are older than the layers at the top, because snow keeps piling on top, so the oldest ones are deeper, scientists can see changes in the trapped gases over a long period of time. The picture shows a 19 centimeter long section of ice from the Greenland ice sheet. Question 13 asks, why do you think the winter layers are darker than the summer layers? And so you can see a variation between winter and summer layers here. You should know that. The reason is in winter, there's stronger winds, it blows more dust, and in the winter you get more dust accumulation than in the summer months. Let's move to page 6. So what we're going to see now is a very famous graph. It's called the Vostok ice core graph, and this shows the temperatures of the last 400,000 years. Okay, how do we know this? By taking samples of what the atmosphere was like in ice cores. It says the data from the graph comes from ice core data taken from the Vostok Research Station in Antarctica. The graph shows the temperature change from 420,000 years ago to the present. When the temperature, I'm skipping to the last paragraph, on the graph shows a change of -3 degrees or lower, Earth was in an ice age. So that is, if you can look at the graph, all right, -3 would be halfway between the -2 and -4. So that's when Earth was in an ice age. On this graph, by the way, present day is on the left side. So our temperatures are up here. Okay, if you can see where I'm looking. If we go back in time, we're moving to the right. So it used to be really cold, right? It used to be warmer, cold. And if we go all the way to 420,000 years ago, that's this point right here. And so as we move from right to left, we're going from 420,000 years ago through time, and we see these spikes. We call those interglacial periods. Interglacial, between the glaciers, between the ice ages. Okay, so let's look at the questions. It says the trend in the graph shows short, warm periods between long periods of highly variable cold climate. Which statement is supported by the information in the graph? The graph shows that the temperature for the past 10,000 years compared with the previous 400,000 years has been doing what? All right, the past 10,000 years compared to the previous 400,000 years. So the past 10,000 years, remember, it's on the left side, right here. Compared to the past 400,000 years, right? Would you say in the past 10,000 years is getting warmer, staying fairly stable, or getting colder? looking at the line of the graph. Next page. Predicting the future from the past. You have just seen these graphs. Use the graphs to describe how current climate trends, the first graph, might change the pattern of warming and cooling seen in the Vostok ice core graph. So this is the first graph we saw, right? From 1880, we saw that the temperature is increasing. And we're going to add that over here. That's what we're seeing over on the very left side of the graph. Understand you'd be going the other direction then to see the future. Describe how current climate trends might change the pattern of warming and cooling, shown on the Vostok ice core graph. So to help you with that, understand what I see in the past is a peak, right? And then it drops off again, or a peak, and it drops off rapidly, a peak. What I'm not seeing now is the dropping off rapidly, right? In fact, what we saw is it's not cooling right now, it's actually warming up. Spoilers, if we were to follow the cycles that cause this, and we'll get to that, we should be entering a 23,000 year cooling trend. This should be dropping off, okay, but it's not. Last page, looking to the future. We want to predict future climate, but simply looking at changes in temperature isn't enough. The Earth is a complex system. Scientists use mathematical climate models to try to predict what will happen to Earth's temperature in the future. The math is very complicated, so we use computer programs to do the calculations. Still, these mathematical models are not complex enough to model the entire Earth system, so scientists design their models to focus on just a few of the components at a time. In the next 4 activities, you'll use some climate models to understand how global temperature is affected by changes in the mixes of gases in the atmosphere. Although scientists generally agree that global warming is occurring, there are still many unknowns about what exactly will happen to Earth's many climates as a result of global warming. So take a look at this. Interesting, right? If we look at and I don't see a title, I would say read the title first. So let's take a look at the axes. The x-axis is showing year. So here's 2000, 2020. So we're somewhere in here, right? 2024-ish. And this is showing some lines. And there's some weird numbers here. Global temperature change in degrees Celsius. So it shows that this one is showing a temperature increase of a little less than 1.5 degrees. This one shows 1.5 degree rise, and so on, 2 degree, 2.5 degree rise. So this says the 1995 IPCC, which stands for the Intergovernmental Panel on Climate Change, report projected global mean surface temperature changes from 1990 to the year 2100 for the full set of different emission scenarios. All right. A climate sensitivity of 2.5 degrees Celsius is assumed. Climate change, it says, where it's from. So question 16, it says, how can scientists be both fairly certain that Earth is warming and still actively researching unknown factors? All right, so what is that saying? It's saying, how is it? We know Earth is warming. We can measure all that, but we're still researching because we don't know what we don't know. The climate system is very complex. There are a lot of variables to get into. So I just want you to understand from this that yes, we know it's warming, but when we try to predict the future, there's a lot of scenarios, a lot of variables that we're not sure about. Okay? So that is the lesson. It went a little faster than I had expected. Now, going back to the assignment, you will see on the side here, you have HASBOT Activity 2 exit quiz to do. You should do that right now to check your understanding of this lesson. Any questions? Let me know.